All right, let's take a look at another topic. This is called how to complete the square. There's a few steps to this, so I'm probably going to end up making 2 or 3 videos. But first of all, what we're going to look for is basically what's called a perfect square in algebra. Now, if I have a trinomial, let's say I've got an x squared plus, let's say, 4x plus 4. This is a trinomial. It's also a perfect square. That is, if we look at a binomial of this, that is a two-term expression, we can actually break this up into an x plus 2 and an x plus 2. And because we can express that as x plus 2 all squared, these are basically what we call perfect squares. So that's what we're trying to do. We're trying to get a perfect square and some other bits tacked on the end, quite possibly. So that's what we're trying to do. Now, in this equation here, it automatically forms this. And we can see that when we factorize it. But what say it doesn't? Let's say, for example, I've got some examples here. I'm going to use exercise, this is, what was it, 17.06 from the Theta mathematics book. Let's imagine we've got question 1. And question 1 reads, and it's got x squared plus 4x minus 7. Well, we want to find out if this has got a perfect square, or rather we're going to find a perfect square within this, and it may be, if it's not all complete a perfect square, it might be some bits tacked on the end. Well, let's see how that plays out. So what we go ahead and do is this. In fact, I'm going to restate this. So I'm going to go x squared plus 4x minus 7. And then what I'm going to do is I'm going to make the minus 7 out a bit further. So I'm going to make a bit of room in there. Here it is. Get rid of that bit too while I'm there. Okay, here we go. So I'm going to stretch out the minus 7, pop the minus 7 in over there. Then what I'm going to do is in the gap here, I'm going to take the b term. In this case, the b term is a positive 4. So I'm going to add the positive 4, divide it by 2, and square it. This expression here is my perfect square. That in itself is a perfect square. And we know it is because I've got an x squared plus 4x plus 4 divided by 2 is 2, and 2 squared is 4. We have, essentially, that bit there, here. They're both the same. But this is a different expression. So when we come to find the perfect square, we're actually going to have to do something a little bit different. So I've added 4, the b term, divided it by 2 and squared it. And if I add it, I've got to subtract it. And then, of course, if I then subtract it, 4 divided by 2 all squared, by adding it and subtracting it, the net result is 0. In fact, if I cross that out and cross that out, because that minus itself is 0, I'm back to x squared plus 4x minus 7. So it's the same thing, but it's just that the moment I take the b term, add it, halve it, and square it, and then subtract it, halve it, and square it, the added portion is a perfect square, and we've got this bit tacked on the end. So let's go and redo that again, and this time we're going to actually complete the square. So I'm going to go equals, and I've got my x squared plus my 4x. I've got my b term. I'm going to add the b term on, halve it, and square it. I got my minus 7 on the end, but then I'm going to subtract the b term, halve it, and square it as well. Now, this bit here is my perfect square. Now, sometimes it's not obvious that this, in fact, actually is the same as this or some other expression. So we can actually very quickly find the perfect square here by doing one simple thing. Put our brackets, our x, we square it, and the value inside the brackets, not the square, not minus, positive, anything else, the value inside this bracket bit here is going to be the value we're going to place here. So what's 4 divided by 2? That's the only question. Don't worry about the square. 4 divided by 2 is 2. It's a positive number, and we're going to place it there. That's our perfect square. And you'll recall from before, we actually got that. We got an x plus 2 all squared. Now, We've also got this bit tacked on the end here, so I'm going to write that in minus 7 minus, and I can actually go, well, what's 4 divided by 2 is 2, all squared is 4. There it is. So now I'm going to have x plus 2 all squared minus, well, minus 7 minus 4 is going to be 11. And there is my perfect square. Or sorry, that is my completed square. That's a perfect square. This is what we call the completed square. And that's what we are after. I'll just use a kind of a looking sort of like a square there. All right, hopefully that makes sense. We're going to do a whole bunch more. Anyway, that was Theta, 1706, question 1. I'm going to work my way through a whole bunch of these, and hopefully these will start to make sense.